Good morning, all. Welcome to the Geology lab session. And I'm Dr. Chandrasekhar Pagasnarli, Assistant Professor, Civil Engineering Department, BMSIT Institute of Technology and Management, Bangalore. Today, I'm going to explain about the metamorphic rocks. So, what do you mean by metamorphic rocks? This metamorphic rocks are derived from the pre-existing rocks called sedimentary as well as the igneous rocks. And metamorphic rock is nothing but it's altered rock. So altered rocks, altered means the original textures and the chemically, the mineralogical, physical, and appearance will be completely changed, completely altered due to a high temperature and pressure condition of the particular areas. That's why we call it as an metamorphic rocks, called altered rocks. So here, how to identify these rocks? So there are the physical properties of metamorphic rocks. So you can see that by color and by textures, by grain sizes, mineral present, and specific gravity, mode of formations, occurrence, and uses, and where we are using. And of course, the textures, grain size, and mineral composition is the essential part, which you can see that you can easily identify these rocks, and remaining part of the occurrence and even uses or the rest of the part will be there. So let's start with we have with us today about the metamorphic rocks. This is called a gray gneiss. It's a gray color. It's a gneiss which is derived from the granite. Okay, and this is called the phosphate quartzite, and it's very typical one. It's a phosphate quartzite, and it's derived from especially the sandstone quartz and thermal. It's called a thermal metamorphism, and here it is a marble. This marble, and this is a granite. This is a gray granite. It's derived from the gray granite. We call it as a gneiss. And this is derived from the sandstones becomes a quartzite. This is a mode of formation of the metamorphic rocks with a pre-existing one. And this is a gray, the sandstone, the marble, which contains earlier it was the limestones and become the marble. That's why we call it as a thermal metamorphism. There are three types of metamorphism: thermal metamorphism, contact metamorphism, dynamo-thermal metamorphism. Three types of the metamorphic process are there. And under which circumstances, which rock derived from the which the rock, that we need to identify it by looking the textures, by looking the grain sizes, okay, and this occurrence part. So when it comes to the micaceous schist, especially this micaceous schist, generally this schist, it's earlier it was previously it is a shale, maybe a shale, or then it becomes a slate, then it can become the phyllite, then become the schist. This is called an thermodynamic metamorphism. So this is all the four stages. It is crossed. Now it can become the schist. And further, it may be changed. If it is in the ground size, it may be changed. It's a continuous process. Okay, it's a continuous process. And when it comes to the phyllite, this is a phyllite part, and which is generally shale becomes slate and then become the phyllite. There are three stages of this metamorphic rock. That's called a phyllite. That's called a thermodynamic metamorphism. Okay, and this gneiss, phosphate quartzite, marble, micaceous schist, and this is called a phyllite. And these are all called metamorphic rocks. What we have with us today for this session, and these are the textures. Then especially in the grain size. So in the gneiss, the textures will be the gneissic textures. You can see these flow textures here. This is called a gneissic textures. Gneiss textures will be there. Okay, and especially in the quartzite, there will be different types of textures. Especially in the phosphate quartzite, granular textures, grain sizes will be. In this marble also it's a granular textures, and in mica it's a schistose. You can see the schistose structures. Right. This is schistose structures. Okay, and it's especially in the phyllite, you can see this slatish textures. Slate. It's flat like a structures. This is a typical textures of metamorphic rocks. And the mineral present, especially in the grey granite, it's a quartz and feldspars. Nothing is changed there. And remaining even here also, so quartz and feldspars will be there. But in marble, it's this is a completely calcite. Okay, it may be this is a granitic garnet and mica will be there. Garnet and mica. This is completely the garnet. You can see this. Garnet is here. You can see this. You can see this. This is a garnet and this is a mica. This is a muscovite as well as the biotite mica. You can see the shining one, and here you can see the calcite. If you want to identify whether it's calcite is there or not, you can put some the diluted HCl. It will definitely react with the things. Now let's go with the phosphate quartzite. It's completely it's a quartz part. So specific gravity, each of the rock will give the different specific gravity. Some are maybe the high, some are maybe medium, some are maybe the low. Depends on the mineral present in the particular rock. Okay, and mode of formation, it will be the thermal metamorphism, dynamic metamorphism, or it may be the what you call dynamic metamorphism. Okay, depends on the mode of the environment occurrence. And generally we use this metamorphic rocks for flooring and building stones as a building stones, and also we use it for the tabletops. Okay, most of this igneous, sedimentary and metamorphic rocks are used for as a building stones, and depends on the strength of the rocks we allotted. We will use it for the for road metals, construction of building stones, for aggregates, railway ballast. Okay, almost all the raw materials we use it from the igneous, sedimentary and metamorphic rocks for civil engineering projects. That's all about the metamorphic rocks sessions. Thank you very much for participating in this session. Thank you.